What shall we do? We shall continue with sketching the graph of an ellipse. Example 1.20, sketching the graph of an ellipse with center of the origin. So let us pay attention to an ellipse whose standard equation is given by this y squared over 36 plus x squared over 20 is equal to 1. Find the foci, vertices, endpoints of your minor axis, and sketch the graph. So between these two denominators, which is a squared? The larger denominator is going to be a squared. So this is a squared. This is b squared. A squared appears under y. So that means our principal axis is vertical. It is standing up. So we shall need a. So this is a squared. A is 6. Okay, the square root of 36 is 6. So we shall need a to locate the vertices of your ellipse. And this is b squared. So the square root of that is b. And we shall need that to locate the endpoints of your minor axis. Okay, so let us produce, Okay, so let us produce the vertices, the coordinates of your vertices, the endpoints of your minor axis, and the foci. So what would be the coordinates of these points? Well, let us first produce the values of a, b, and c. So what is a, b, and c? A squared is 36. So a is 6. B squared, okay, so this one is b squared. So b squared is equal to, okay, we can write 20 as 4 times 5. Okay, square root of 4 is 2. We can just leave this one as square root of 5. What is c squared? We shall need c to locate the coordinates of your focus. C squared is equal to a squared minus b squared. So 36 minus 20 is 16. C is 4. The square root of 16 is 4. Let us locate the points that will help us sketch the graph of your ellipse. So we have to be careful here. Okay, so the first guide is our axis, or our principal axis is vertical. Okay, so it's standing up. So that means, okay, we shall locate the vertices up and down, above the center and below the center. How do we locate it? We need a. We just add a. Okay, so 2, 4, and 6. So that is 1 vertex. We subtract 6. Okay, so this one will be -2, -4, -6. That would be another vertex. How about the endpoints of our latus rectum? No, not the latus rectum, okay? But the endpoints of your minor axis. We shall need b. Okay, so b, 2 times square root of 5 is approximately 4.47. So we add 4.47 from the x coordinate of your center. All right, that's one endpoint of your minor axis. To locate the other endpoint, we subtract 2 times square root of 5, which is approximately 4.47. So 0 minus 4.47 is -4.47. So this would be the point. Its coordinates would be this one. This problem does not require us to produce the latus rectum. I don't know, maybe another problem, maybe we shall see another problem later on wherein we must produce the endpoints of our latus rectum. What would be the focus? So the focus and the vertex, they are collinear with the center. So we shall locate along this major axis the focus. We shall need C to locate the foci. So from our center, we add 4 up and we subtract 4, 2, 4, -2, 4. So those 2 points would be the coordinates of our foci. So we now have our vertices, V1, V2. We now have our endpoints for the minor axis, B1 and B2. So we can carefully trace an ellipse. So that one would be the sketch of the graph for our ellipse, whose equation is y squared over 36 plus x squared over 20 is equal to 1.